In this video, we will talk about frequency analysis of speech and PPG signal. For this frequency analysis, we will use the DFT algorithm. First, let us understand the program for calculating the magnitude response. Here are the array declarations, and here is the serial dot begin with baud rate. Here f real represents the real part of the frequency component and f mag the imaginary part of the frequency component. And according to the DFT matrix method, using that formula, this algebraic sum gives the real part and imaginary part, and from there the magnitude response is calculated as squares of the real part and imaginary part and taking the whole square root. And from the magnitude response, the dominant frequency can be found by finding the highest peak and then converting it into the required frequency. So let's run this program. Here you can see the magnitude response of the speech signal like this. Here you can see that the maximum is attained here at this point, and here you see that the dominant frequency is around 200 Hz. It's approximate. Now let us try for PPG signal. For the PPG signal, N is equal to 256 and the sampling rate is 100. Now let us see the magnitude response. Here you can see the magnitude response. You can see that it is mirrored around the central point. Now what we have to do, we have to filter out the very low frequencies, frequency below 0.5 Hz and frequency greater than 30 Hz, which will also filter out the power line interference. For this part, we don't need the imaginary calculation of the magnitude, we only need the real and imaginary part. So we will comment those portions of the code which we don't need. Now in this part, I remove the required components. That means I have to make those components 0 in the frequency response. Since it should be less than 0.5 Hz, I have calculated that for all n less than 3, the real and imaginary parts should be made 0. And since it is symmetric about the central point, we need to do the same thing from the other side. So that's why for k greater than 508, which is less than 511 minus 3, it should become 0. The real and imaginary part should become 0. And this corresponds to filtering out frequency greater than 30 Hz. Now here I am calculating the inverse DFT. Now let us have a look at the output and see if it is really getting filtered out. Now let us look at the output of the serial plotter. Here you can see the output of the serial plotter. Here the blue one is the actual PPG data and the red one is the filtered PPG data. You can see that there is a baseline wonder in the original PPG data which was removed after the filtering, and the DC component also has been removed. You can see here the shift DC component has been removed. I hope you liked the video. Thank you.